Hello everyone, welcome to Helm of Science. So I hope that all of you are studying hard. So in this video, we will talk about the important questions on limits based on class 11 syllabus. Okay, so without any further delays, let's get started with the questions. So the first question that we have to evaluate this limit extends to 0 root over 1 plus x square minus root over 1 plus x by root over 1 plus x cube minus root over 1 plus x. Okay, so as you can see here, if we put x equal to 0, it will be 0 by 0 form. Okay, so I've written here 0 by 0 form. So we have to just evaluate the limiting value of this, okay, of this function. So here we will do rationalization of both numerator and denominator. Okay, since we have both terms of root in the numerator and denominator, we will rationalize both the numerator and denominator with their conjugates. Okay, so in the next step we will get limit extends to 0 to 1 plus x cube plus 1 plus x into 1 plus x square plus 1 plus x. Okay, now it will be limit extends to 0. This will be what? 1 plus x square whole square minus 1 plus x whole square into root over 1 plus x cube by 1 plus root over 1 plus x, and in the denominator we have 1 plus x cube whole square minus root over 1 plus x whole square into root over 1 plus x square plus root over 1 plus x. Okay, so this will be limit extends to 0 x square minus x. If we just simplify this one, that is, if we simplify this part, we will get x square minus x into we have root over 1 plus x cube plus root over 1 plus x, and in the denominator if we solve this one, then we will get what? We will get x cube minus x into we have 1 plus x square obviously under root plus root over 1 plus x. Okay, now we take x common, it is x, so it is x minus 1 into root over 1 plus x cube plus root over 1 plus x by it is x square minus 1 into root over 1 plus x square plus root over 1 plus x. Okay, now it will be limit extends to 0 x into x minus 1 into x into, now what is a square minus b square? You have, see, you have got here x square minus 1, that means 1 can write into 1 square, so it is a square minus b square formula, so it is x plus 1 into x minus 1, and remember obviously you have this one, it is 1 plus x square plus 1 plus x. Okay, now here as x tends to 0, therefore x is not equal to 0. Again, as x tends to 0, therefore if we write in this way, that if we subtract 1 in both sides, then what? X minus 1 is tending towards minus 1. That means what? That means x minus 1 is also not equal to 0. Okay, so if x is not equal to 0 and x minus 1 is not equal to 0, then we can cancel out this x into x minus 1 and here x into x minus 1 in the numerator and denominator. Okay, so this and this cancelled out. So what we are left with, limit extends to 0, we have 1 root over 1 plus x cube plus root over 1 plus x by x plus 1 into root over 1 plus x square plus root over 1 plus x. Okay, now here we will put the limiting value, that is we will write in this way, that is remember it is not that x is equal to 0, we are putting the limiting value. Okay, as x is tending towards 0, so we are writing 0. This is the limiting value. Okay, so in place of x I have just written 0. Okay, so it is 1 plus 1 by 1 into 1 plus 1. Okay, so it is what, 2 by 2, that is equal to 1. So this is the required answer for this question. Okay, so I think you have understood this. Now we come to the second question. Okay, now here also we have to evaluate this function, that is limit extends to 0, sorry, limit extends to 2, x cube minus 4x square plus 4x by x minus 4. Okay, so here also if we put x equal to 2 in the first step, you can see it will be 0 by 0 form. Okay, so you have to solve this one. So how we can do this? See, this limit extends to 2. Here we can take x common. So it will be x square minus 4x plus 4 by we have x square minus 4. Now this can be written as limit extends to 2. Now what is this one? This is x square minus 4x plus 4. You can get a whole square format from this. So it is x square minus 2 into x into 2 plus 2 square. I can write like this. So it is what? It is x minus 2 whole square by we have x square minus 4 means what? X square minus b square formula. So x plus 2 into x minus 2. Okay. Now here as x is tending towards 2, therefore x minus 2 is tending towards 0. Okay, so as x minus 2 is tending towards 0, therefore we can say that x minus 2 is not equal to 0, and if it is not equal to 0, then we can cancel out 1 x minus 2. Okay, now we are left with limit x tends to 2 x into x minus 2 by x plus 2. Okay, this one we are left. Now we have put the limiting value, that is 2 into 2 minus 2 by 2 plus 2. Okay, this is what? It is 0 by 4. So it is 0. So the limiting value of this one is 0. So this is the answer of this question. Okay, now we come to the third question. Here we have to prove that limit extends to 0, tan x minus sin x by 1 minus cos x is equal to 0. That means the limiting value of this function tan x minus sin x by 1 minus cos x is equal to 0. Okay, so let's take that one. That is, let us first take LHS. So it is what? Limit extends to 0, tan x minus sin x by 1 minus cos x. Okay, now tan x can be written as sin x by cos x minus sin x by 1 minus cos x. Okay, now In numerator, if we take sin x common, it is 1 by cos x minus 1 by 1 minus cos x. Okay, so it is the limit extends to 0 if we take cos x as LCM. So it is sin x into 1 minus cos x by cos x, and we have 1 minus cos x in the denominator. Okay, now this can be written like this as limit extends to 0 sin x into 1 minus cos x by cos x into 1 minus cos x. Now, very important thing I have got to see that here as x is tending towards 0. So if we just apply cos on both sides, so cos x is tending towards cos 0. Now cos 0 is what? 1. So you can write as x is tending towards 0, cos x is tending towards 1. Okay. Now if we just multiply with minus on both sides, then minus cos x tends towards minus 2, sorry, minus 1. Now if we add 1 on both sides, then 1 minus cos x is tending towards minus 1 plus 1, that is 1 minus cos x is tending towards 0. Okay, so as it is tending towards 0, therefore 1 minus cos x is not equal to 0. Okay, so as x is tending towards 0, 1 minus cos x is also tending towards 0, and therefore we can say 1 minus cos x is not equal to 0. Then we can cancel out this and this one. Okay, so we are left with limit extends to 0 sin x by cos x. So it is what? Limit extends to 0 tan x. Okay, now if we apply limiting value, that is tan 0 is what? 0. That means we can write tan of 0, that is what? It is 0, and that we have the RHS proved. Okay, so this was our sum. Okay, now we come to the fourth question. Here also we have to evaluate this function, that is sin x, sin of 4x by sin of 2x, that is limit extends to 0 sin 4x by sin 2x. Okay, now in limits we have learned a formula, that is limit extends to 0 sin x by x is 1. So here we will apply this one, this formula. Okay, so let's see how we can approach this. Here we will write it in this way, that limit extends to 0 sin 4x by sin 2x. Now here we have just multiplied and divide with x, as x is tending towards to 0, therefore x is not equal to 0. Okay, now it is limit extends to 0 sin 4x. Now here we multiply 4, x was there, into, here we write 2x by sin 2x. Now here, since we have just divided this sin 4x by 4, so we have to compensate this one. So we have compensated with 2 only, so another 2 that we are left with, so we write into 2. Okay, so this 2 will, we can write outside, so it is but sin 4x by 4x into 2x by sin 2x. Okay, now this can be written as 2 into limit extends to 0 sin of 4x by 4x by sin 2x by 2x. Okay, now since both are giving us the finite value, will give us finite value, that means both are existing finitely, then we can write it as 2 into limit extends to 0, sine 4x by 4x by limit extends to 0, sine 2x by 2x. Okay. Now, as x is tending towards 0, now if we multiply 4, it is also tending towards 0. If we multiply 2, it is also tending towards 0. Therefore, as x is tending towards 0, 4x is also tending towards 0, and 2x is also tending towards 0. So in the next step, we can write it as 2 into limit. Here we will write 4x tends to 0, sine 4x by 4x by limit, we will write 2x tends to 0, sine of 2x by 2x. Okay. Why we are writing this? See, in the formula, limit extends to 0, sine x by x. This will be 1 when this x and this x will be same. That means the coefficient of x will be same everywhere. Here, if would have been 5x, then would have here would have 5x. If this will be equal to 1, then here and here, these three coefficients will be same. That means whatever is present before x, that will have to be same. Okay. For that, its limit will be equal to 1. Okay, so we are writing this one. Okay, so now we can write it as 2 into 1 by 1. Okay, so our final answer is, okay, this is our required answer. Okay, now we come to fifth question. Okay, so here also we have to evaluate this one, that is limit n tends to infinity 1 square plus 2 square plus 3 square up to n square by we have n cube. Okay, so here actually it is infinity by infinity form. Okay, so here what we do, it is limit n tends to infinity. Now this formula, that is 1 square plus 2 square plus 3 square up to n square, this formula we all know. Suppose the formula that we know, that 1 plus 2 plus 3 up to n, it is n into n plus 1 by 2. So also we know that in GP or AP we have learned this one, that means in sequence and series, that is 1 square plus 2 square plus 3 square up to n square. The formula that we have, it is actually what? It is n into n plus 1 into 2n plus 1 by 6 by we have n. Okay, so this formula you have to remember. Okay, now in the next step what we can write, it is limit n tends to infinity, this is n into n plus 1 into 2n plus 1 by, we can write this one as 6n. Okay, now you can see, as n is tending towards infinity, therefore n is not equal to 0, and since n is not equal to 0, then we can cancel out 1n, it is n square. Okay, now here if we multiply these two terms, that is n plus 1 into 2n plus 1, then we will get limit n tends to infinity 2n square plus 3n plus 1 by we have 6n square. Okay, now as n is tending towards infinity, then we have to take that let z equal to 1 by n. Okay, now as n tends to infinity, therefore z will tend to 0. Okay, as n tends to infinity, z will tend to 0. Okay, now in place of n we can write, that means here we have taken that let z equal to 1 by n, so we can write n equal to 1 by z. Okay, so in place of n we will have 1 by z, so it is limit z tends to 0, 2 into, now since this n square, so it will be 1 by z square plus 3 into 1 by z plus 1 by, it is 6 by z square. Okay, now see, this is limit z tends to 0. Now if we take LCM of z square in the numerator, then we will get 2 plus 3z plus z square by we have z square into, we can write this one as, since it's in a denominator, we can write like this one, that it is z square by 6. Okay, if it is on the, it was on the denominator, then we have written it like this, then it is z square by 6. Now another important thing, that as z is tending towards 0, therefore z is also not equal to 0. And if z is not equal to 0, then we can write that z square is also not equal to 0. Okay, so if it is so, then we can cancel out this z square and z square. Okay, now if I write this one, it is limit z tends to 0, 2 plus 3z plus z square by 6. Now if we put the limiting value of z, that is, it is 0, so it is actually what, I don't have to write mistake, so we can write 2 plus 3 into 0, or you have to don't need to be written. So it is 2 plus 0 plus 0, since it is obviously 0 will be, so it is what, 2 by 6, it is 1 by 3. This is our required answer for this question. Okay, so the evaluated value is 1 by 3. Okay, now we come to the fifth, now we come to what, this was our fifth question. Now we come to sixth question. Okay, now another value that we have to evaluate, that is another function that we have to evaluate, is limit extends to 4 cos alpha to the power x minus sin alpha to the power x minus cos 2 alpha by x minus 4. Okay, so here what we do, it is also 0 by 0 form, you can see here. So this limit extends to 4 cos alpha to the power x minus sin alpha to the power x minus this cos 2 alpha means what, we can write like this, as cos square alpha minus sin square alpha. Okay, by we have x minus 4. Now it is limit extends to 4 cos alpha to the power x minus sin alpha to the power x minus cos squared alpha minus sin square alpha. Now another thing very important, that is, it is here, it is cos squared alpha minus sin squared alpha, so nothing is mentioned here, that means what, it is into 1. Now this 1 can be written as cos squared alpha plus sin squared alpha. Okay, this is a very important step in this sum, since it is nothing here, it is given, so it is what, cos squared alpha minus sin squared alpha into 1, so 1 can be written as cos squared alpha plus sin squared alpha. Okay, by x minus 4 we have, now this can be written as limit extends to 4, this is what, cos alpha to the power x minus sin alpha to the power x minus, now this one is what, you can see that it is a minus b into a plus b, so it is a square minus b square. Okay, by we have x minus 4. Now it is limit extends to 4, it is cos alpha x minus cos 4 alpha minus, I take common, we can write it as sin alpha to the power x minus sin 4 alpha. Okay, by we have x minus 4. Now we separate this, that is limit extends to 4, we write it is this way, that is cos alpha minus cos 4 alpha by x minus 4 minus limit x tends to 4, it is sine alpha to the power x minus sine 4 alpha by we have x minus 4. Okay, so it is what? Now another very important thing. Now from this I will take cos 4 alpha common into limit, since it's a constant will go outside, so into limit x tends to 4. Now this will be what? Cos alpha to the power x minus 4 minus 1 by x minus 4. Okay, I have taken a cos 4 alpha from here also. Then what will get? We will get cos of x minus 4, and if we just multiply this one, it will get same as this one. Okay, so I have written like this. Okay, so in the second case we will also do the same. We will take sine 4 alpha common into limit x tends to 4. It will be sine alpha to the power x minus 4 minus 1 by x minus 4. Now as x is tending towards 4, therefore x minus 4 is tending towards 0. Okay, so we can write that cos 4 alpha into limit x minus 4 tending to 0, cos alpha to the power x minus 4 minus 1 by x minus 4. Okay, minus sine 4 alpha limit x minus 4 tending towards 0, sine alpha to the power x minus 4 minus 1 by x minus 4. Now in limit we have read a formula, that is limit x tends to 0, a to the power x minus 1 by x. It is what? It is ln a provided a greater than 0, obviously. Okay, so we will write like this, that is here our a is what? In this case it is cos alpha, and in this case it is sine alpha. Okay, so we will write that cos 4 alpha into ln cos alpha minus sine 4 alpha into ln sine alpha. Now here a condition was mentioned, that is 0 less than alpha less than pi by 4. Now in this interval both cos and sine are positive, so cos alpha and sine alpha are positive. So it is given that this interval, that means here ln of cos alpha and ln of sine alpha means what? This both cos alpha and sine alpha has to be greater than 0. That means it has to be positive. So this interval was given that it is 0 to alpha, between, that means it is lying from 0 to pi by 4. In this interval both cos and sine are positive. Okay, so our final answer that we have is actually what? Cos 4 alpha ln cos alpha minus sine 4 alpha into what we have, it is ln sine alpha. Okay, ln sine alpha. So this is our required answer. Okay, now we come to our question number 7. It is given, find limit x tends to 0 of fx where fx is equal to mod x by x when x is not equal to 0 and 0 when x is equal to 0. Now before we start this sum, all of us know the concept of mod x, that is mod x is what? It is actually root over of x square, which is x when x greater than 0 minus x when x less than 0 and 0 when x is equal to 0. Now here it is given function that fx is equal to mod x by x when x is not equal to 0. So here we have to deal with the LHL and RHL of this fx. That means we have to check whether the function is existing or not. That means whether limit extends to 0 fx exists or not. That means we have to check LHL and RHL of fx at x equals to 0. Okay, then we can say that if LHL and RHL will be equal, then we can say it is existing and it is equal to a finite limiting value. But it is not equal, then we can say that it is not existing. So let at first take the LHL of fx at x equal to 0. Okay, so this is what limit extends to 0 minus LHL means 0 minus of fx. So limit extends to 0 minus mod x by x. Now when x is 0 minus, that means x is tending towards 0 minus means what? When x tends to 0 minus, that means x is less than 0. So when x is less than 0, then what is the value of mod x? It is minus x. So it is minus x by x. Okay. Now as x tends to 0 minus, therefore x is not equal to 0. Therefore we can cancel out this one. So it is actually what? It is minus 1. So we have got the LHL value of fx at x equals to 0 is equal to minus 1. Okay. Now we take the RHL part. RHL of fx at x equal to 0. So it is actually what? Limit extends to 0 is limit extends to 0 plus RHL means on the right hand side of the x equal to 0. That means just slightly, that means infinitesimally small quantity. It is just infinitesimally small quantity bigger than 0. That means it is on the right hand side. That is limit extends to 0 plus of fx. That is what? Limit extends to 0 plus of mod x by x. Now limit extends to 0 plus means x is greater than 0. So when x is greater than 0, then what is the value of mod x? This is x. Okay, so x by x. Now as also here x is tending towards 0 plus, therefore x is not equal to 0. So we can cancel out this one and it is equal to 1. Okay, so here you can see that LHL and RHL value is not equal. LHL is minus 1 and RHL is 1. So we can write that LHL equal to minus 1 and RHL equal to 1. Okay, so we can write that LHL is not equal to RHL. And if LHL is not equal to RHL, then we can write that limit extends to 0 fx does not exist. Okay, at x equals to 0, LHL and RHL are not equal. So we will say that limit extends to 0 fx does not exist. Okay, so here the question that we have to find, limit extends to 0 fx, it does not exist. Okay, so this is our required answer for this question. Okay, now we come to last question of today's class, that is number 8. Okay, so it is given, suppose a function fx is given, that is a plus bx when x is less than 1, 4 when x equal to 1, and b minus ax when x is greater than 1. And it is given a condition, that is if limit extends to 1 fx is equal to f of 1, then what are the possible values of a and b? That means here at x equal to 1, the value that we will get, that is equal to 4, it is equal to the limiting value of fx at x equals to 1. Okay, so here we have to find out the LHL and RHL part. Okay, then we have to equate this one. Here it is not the case that LHL RHL will be not equal. It will be come out as a variable. That means it will be come out as a plus b. That means here it will come out as a expression with the variables a and b. So here we can equate this LHL and RHL, since it is given that limit extends to 1 of fx is equal to f of 1. Okay, so here, and if it is given, that means what, limit is existing. So here, if you take the RHL or LHL first, if you take the LHL first of fx at x equal to 1, so it is what, limit extends to 1 minus of fx. Now when x is less than 1, 1 minus means less than 1. So when it is less than 1, what value we will take? This one, that is a plus bx. So it is limit extends to 1 minus of a plus bx. Now we will write the limiting value, that is it will give us a plus b only. Okay, now after this we will find RHL of fx at x equal to 1. So it will be what, limit extends to 1 plus of fx. Now when it is 1 plus means it is greater than 1, so we will, this function we will take. Okay, so it is limit extends to 1 plus b minus x. Now it will give b minus a. Okay, if we put the limiting value of x. So now it is given that limit x tends to 1 of fx. This is fx is equal to f of 1. Now f of 1 we know is given, f of 1 is equal to 4. Okay, so here it is limit extends to 1, fx is equal to f of 1. That means here LHL will be equal to RHL will be equal to f of 1. That means we can write it in this way, that a plus b is equal to, or you can write in this way elaborately, that is LHL equal to RHL. Since this limit is equal to f of 1, that means the limiting value is existing. Now if limiting value is existing, that means what, LHL will be equal to RHL and it will be equal to f of 1. Okay, now LHL, the value we have got at a plus b, and RHL we have got b minus a, and f of 1 is what, 4. Okay, so now we have got two equations, that is a plus b equal to 4, it is one equation, and we have got minus a plus b is equal to, this is second equation. From this we have to find a and b. We have to find the possible values of a and b. In the question it was given, so we have formed two equations. Now we will solve these two equations, that is a plus b equal to 4 and minus a plus b equal to 4. So here you can see this and this cancelled, a cancelled, so 2b equal to 8. Okay, so if 2b is equal to 8, then b is what, b equal to 4. Okay, now from 1 a plus b is equal to 4. Now a is equal to what, 4 minus b. Now what is b? B is equal to 4, so 4 minus 4 equal to 0. So a is equal to 0 and b is equal to 4. So this is our required possible values, or actually values obviously, because it is a or b. A and b are 0 and 4 respectively. Okay, so this is our required answer. Okay, so that's all for today. I hope that all of you have understood the problems. Okay, and if you do, then please share it among your friends and subscribe to our channel Helm of Science for more of such question answer sessions. Okay, so until then, keep studying hard. Thank you so much for watching.